Hi everyone, today we're going to talk about section 3.4, which is synthetic division. And synthetic division is a way to solve for polynomials. So by using synthetic division, we'll be able to find roots, we'll be able to find remainders, and figure out if a function goes through the factor that we are given. Okay, and there are a few things to remember when dealing with synthetic division. First, you want to make sure that your equation needs to be written in standard form. And what standard form means is that we want the highest degree first, and then it's going to decrease from there. Okay, so if you have x to the fifth, that's going to go first, followed by x to the fourth, x to the third, and so on. And then the next thing we need to remember for synthetic division is that if there's a missing degree, so let's say you don't have x to the fourth, but you have an x to the fifth and you have an x to the third, then you are going to use a 0 as a placeholder. So we want to make sure that all of our terms are accounted for, even if they're not actually there as part of the polynomial. We're going to put in a 0 to show that we know they're supposed to be there, so it's a placeholder, okay? Now we're going to write down the steps, and here's what it's going to look like. So we are going to we're going to draw our division symbol when we have the polynomial. We'll do a few examples here. At the top, here are going to be your coefficients for your terms. So whatever number's in front of your x to the fifth, whatever number's in front of your x to the fourth, and so on. This is going to be your root that you are dividing by. That's going to go out here. And then we're going to follow this process. So first we're going to bring down the first coefficient. So whatever the first coefficient is, you're going to bring it down. Then you are going to multiply. We are going to multiply whatever number you get here by the root. Okay. Whatever your answer is there, we are going to add. So whatever this times this is, we're going to put right here. And then we're going to add the next coefficient in our answer. And that's going to go right here. And then we're going to repeat that process. Okay, so again, this will make a lot more sense once we actually start practicing. If you have a remainder, so the remainder is going to be the last number that you get over here at the end of your division. We are going to write it as the remainder, whatever that is, over our factor, our original factor that we divided as, okay? So a few things to remember before we start our first example. Make sure it's written in standard form, highest degree first, and we're going to use zeros as placeholders, and we're going to practice dividing. So let's go to the first example. In this first example, we have our highest degree is x to the fourth. So I want to make sure that my numbers here are going in that order. So x to the fourth, and then x to the third, x to the second, x to the first, it's technically there, and then my constant, which would be x to the 0. So that's already in order, no need to rearrange it there. So I'm going to identify my coefficients here. Here's my coefficient for x to the fourth. Coefficient, 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 and then constant. So these are the numbers that are going to go in my division. So those numbers are going to be the top numbers. These are the coefficients. So 4, positive 29, positive 4, negative 14, you want to bring that sign with you, and positive 37. So that's how I determine which numbers are going to go above there based on my coefficients for my polynomial. Then my root, this is what you are dividing by. Now, we are not going to put the whole x to the 7th outside. First, we need to set this factor equal to 0 to determine what x we are dividing by. So I subtract 7 from both sides, and I get x equals negative 7. So that negative 7 is going to come out here. That's our root. Okay, and then I'm going to start the process. When I look at my steps, first it says to bring down. So step 1 is bring down. I'm going to bring down the first term, 4. Second step is to multiply. So I'm going to multiply 4 times negative 7 is negative 28. And I'm going to write down the number right there. Then I'm going to add straight down. So 29 plus negative 28 gives me a positive 1. And then I repeat the process. 1 times negative 7 is negative 7. Then I add 4 plus negative 7 gives me a negative 3. And I repeat. Negative 3 times negative 7 is positive 21. And I add negative 14 plus 21 is positive 7. And I keep repeating. 7 times negative 7 is negative 49. When I add those together, 37 plus negative 49 gives me a negative 12. So I'm going to clean this up a little bit so we can talk about what our answers mean. Okay, so we said that the very last number would be our remainder. This is going to be my remainder. So I need to remember that my remainder is going to be written as a fraction, so I will get there. So when you divide the polynomial, when you use synthetic division, you want your answer. These are going to be new coefficients for your answer. Now your answer is going to always start, so let's make another note. It's going to start with 1 less degree than you started. So if my original problem was x to the 4th, my first one should be an x to the 3rd, okay? So I'm going to take my coefficients here. I have 4. So I have 4x to the 3rd. Again, you want to start with 1 less than the original. And then I have a positive 1, so I'm going to bring plus 1 x squared minus 3x, positive 7, plus 7, and then this is a minus 12 over x plus 7. So remember, you're going to put your remainder above the factor that you divided by. So this is the factor I divided by, so I want to make sure that's in the denominator. Okay, so this is how you apply synthetic division. The purpose of synthetic division is to take away a degree. You're dividing, you're making it smaller. So because I started with x to the 4th, my answer is going to start with x to the 3rd, and these numbers become the new coefficients for my new polynomial that I found. So here we have an example of where we are going to need a placeholder for x to the 3rd. Okay, so I have 5x to the 4th, and then I don't have an x to the 3rd. So when I'm writing down my coefficients, I need to make sure I use a 0 as a placeholder before I go on and put negative 2. If I don't put in the placeholder, then I'm going to get this whole problem wrong. So please make sure you check for that. Then keep going with your coefficients. We have a positive 15 and a negative 10. And this is going to be the numbers that I'm going to use for my division. This factor, you first have to set it equal to 0 and solve for x. So because it's giving me the factor, I have to set it equal to 0 and find the x value of my factor, not necessarily just the factor there. So I'm going to divide by a negative 2 here and use the same process. So I'm going to bring down the 5. 5 times negative 2 gives me a negative 10. Add 0 plus negative 10 is negative 10. Multiply negative 10 times negative 2 is a positive 20. When I add negative 2 plus 20, I get a positive 18. Keep going. 18 times negative 2 is negative 36. I add positive 15 minus 36. That's going to be a negative 21. and then multiply negative 21 times negative 2 gives me a positive 42, which when I add negative 10 plus 42 is positive 32. That last number is always going to be your remainder, so that's a positive 32. And remember, I'm going to put it over the factor, x plus 2. This factor comes from what I divided by, but it's the actual factor, not the number that I divided by. And then these are your new coefficients. So how do I know what I'm going to start with? It's always one less than your original problem. So my first term should be x to the third because I originally started with x to the fourth. And these are the coefficients that go with this. So this is a 5 minus 10, and the one that would go after that is x squared plus 18x, and then minus 21 there, and then plus 32 over x plus 2, which is our remainder. Okay, so all of this would be your answer if we're asking you to divide or find the quotient. That is your solution, your answer, your new polynomial with the remainder if there is one. Okay, and then we have the remainder theorem. And the remainder theorem says that if a polynomial is divided by a factor x minus c, then the remainder is the same thing as f of c. So you have seen this formatting before. F of c means that if I substitute in c into the polynomial, then I get an answer, right? And so this is the same thing. We're just using a new method to find it. So here I have a polynomial. I'm checking to see if I'm going to need any placeholders, any zeros for placeholders. So it looks like I'm good. I have x cubed, x squared, x, and then my constant. So those are going to be my coefficients that I write down. And I'm going to divide by this factor. So again, when you are given a factor, you're going to set it equal to 0 and solve for x. So I have x being 4 here. And I'm going to follow my same process. Bring down the 2. 2 times 4 is 8. Add negative 11 plus 8 is negative 3. Multiply. Negative 3 times 4 is a negative 12. Add 13 plus negative 12 is 1. 1 times 4 is 4. And I add and I get negative 40. Okay? So here is my answer. The remainder, negative 40, is actually going to be my solution. Whatever my remainder is, that is what f of c would be. So if I were to substitute my original 4 into this polynomial, 13 times 4 minus 44, I would actually end up with my answer being negative 40. So instead of substituting in x equals 4, I can also use synthetic division by using that factor and getting the exact same number. So this is what the remainder theorem is telling you, that you can substitute in or divide by that factor and get whatever the remainder is. That would be the same thing as you substituting in that number into the original equation. You've done this before, right? You've substituted in numbers to figure out the new value. But now we're showing you another way of doing it through synthetic division. Okay, going to the next page, here's why we would want to use synthetic division, okay? So we're going to be given a polynomial that's not a quadratic. So we spent some time solving quadratics by doing the quadratic formula, by factoring, all that fun stuff. So we know how to solve quadratics. But using synthetic division, we are able to solve for other polynomials that are not quadratic, so trinomials, quartics, and so on, okay? So we're going to be given a polynomial like this, and when it's telling you that x minus 3 is a factor, this is telling you that x is crossing at positive 3. Remember, we take our factor, set it equal to 0, add it to both sides. So one of the solutions here is going to be x equals positive 3. The fact that this is a factor is telling me that when I do synthetic division, my remainder should be 0. So this is a factor that's going to perfectly go into this trinomial. So I'm going to go into synthetic division. These are my coefficients. making sure that it doesn't skip one or anything, that I don't need a placeholder. Okay, so I'm going to do my synthetic division, and I'm going to divide by 3 here. So going through, bring down the 2, multiply 2 times 3 is 6, add negative 3 plus 6 is 3, multiply 3 times 3 is 9, add, I get negative 2, 6 times negative 2 is a negative 6, and when I add, my remainder is 0. Here's a big hint. If your remainder is not 0 and the problem tells you that you have a factor, you need to go back and do it again. I promise you the remainder needs to be 0. So you need to go back and check your adding and your multiplying. Make sure you didn't miss anything, okay? So these are going to be the coefficients of a quadratic. Remember that your solution, whatever you get, is 1 degree less than what you started, okay? So this quadratic, I know how to solve this quadratic now by factoring or using the quadratic formula, because that's what we've been doing over and over. So you're going to use synthetic division to get to a quadratic so you can solve it. So I'm going to go ahead and factor. You do whatever you feel more comfortable doing. If you aren't loving factoring, but you can use the quadratic formula, please do that. So two numbers that multiply to negative 4 but add up to a positive 3. I'm going to go with 4x and negative 1x. I'm going to use these numbers to break up my middle term. So this is going to become 2x squared plus 4x minus 1x minus 2. And this is factoring by grouping. So I'm going to group the first 2 and the last 2. Here I can factor out a 2x, leaving me with x plus 2 on the inside. And here I can factor out a negative 1, leaving me with x plus 2 on the inside. So whatever two numbers or factors match, that's going to be one of my factors, so x plus 2. Whatever I took out, that's going to be another factor, 2x minus 1. So in order to see where the graph is going to cross, I need to set these factors equal to 0 and solve. So I get x equals negative 2. Here I get 2x equals 1 divided by 2, x equals 1/2. Okay, so I'm negative 2, 1/2. And here's how I know I need one more answer, because my coefficient for my original problem is x to the 3rd, which means I need 3 solutions. And please do not forget, you were already given a factor to begin with. So x equals positive 3 is also going to be one of your solutions. Don't forget that positive 3. So this is going to be your final answer, 3 solutions, because we're talking about a trinomial. So I need to make sure that I have 3 solutions total. Okay? Going to the next example here. Again, I have a trinomial x to the 3rd to start off. So I'm going to write down my coefficients. I have 15, 14, negative 3, negative 2. No need for a placeholder this time. Now, this time the problem is given to me a little bit different. I'm not given a factor anymore. I'm given a 0. So same thing. This means that this graph has a solution at negative 1. Now I have to find the other 2, okay? So negative 1 is what I'm going to divide by. You only set it equal to 0 and solve for x when you're given a factor. But when you're giving a 0 or an intercept, that is what you were going to divide by, and that is one of your solutions. Okay, so I'm going to go through the motions here. Bring down, multiply, add, multiply, add, multiply, remainder 0. Again, big hint, if you do not get a remainder 0, when I'm telling you this is a solution or a 0, you need to go back and check your math. You should get a remainder 0. So these become my coefficients for my quadratic now. And again, I know I need to start with x squared because I started with x to the 3rd, so you always start with 1 degree less. And do quadratic formula or factoring. It's not going to do you any good to just copy my work if you don't understand how factoring works, okay? At this point, we need you to do whatever you are most comfortable with. So I'm looking for two numbers that multiply to negative 30x squared but add up to a negative 1. And so that's going to be negative 6x and positive 5x. So I'm going to use these to break up my middle term. Here I have 15x squared, and then I'm going to go with plus 5x minus 6x minus 2. Factor by grouping my first two and my last two. The first term has 5x in common, so I take out a 5x. That leaves me with 3x plus 1. And the second factor, I can take out a negative 2, and the inside is 3x plus 1. So again, your new factors here are 3x plus 1 and 5x minus 2. I'm going to take each factor and set it equal to 0 to solve for x. This one gives me x equals negative 1/3. This one gives me, x equals positive 2/5. I can't forget about my original 0 that was given to me, and then my other answer is negative 1/3 and positive 2/5. So I need 3 solutions because this is a cubic, so 3 solutions for x to the third. Okay, so again, you can either be given a factor, a 0, or we can give you a visual here. So giving you a visual of what the solutions should be. So the equation x cubed minus 4x squared plus 5 equals 0 is graphed below. Use the graph to solve the equation and find all the roots of the function. So if these were perfectly crossing perfect numbers on the x-axis, this would be easy, right? I would just identify like, oh, here, here, and here. But there's only one number that it crosses perfectly and nicely, and that's at negative 1. So this is what I'm going to be dividing by. The other ones are like somewhere between, which tells me that when I get my answers, I'm going to probably have some radicals, some decimals there. It's not going to be super pretty, okay? We do have to use the coefficients from my original equation. So I have 1 for x cubed. I have a negative 4 for x squared. Please note there is no x, so I have to use a 0 as a placeholder. And last I have a 5, okay? So I'm going to go through the motions for synthetic division. Bring down the 1, multiply, add, multiply, add, multiply. And I get a remainder of 0. Another hint here, if you do not get a remainder 0, you should, because we just divided by one of the solutions. So my remainder should be 0. Now the new quadratic I'm working with is x squared minus 5x plus 5. I'm going to try to factor this, but then find out that it doesn't factor. So how else do I know how to solve a quadratic? By using the quadratic formula. Identify your a is 1, your b is negative 5, and your c is a positive 5. Go through and use the quadratic formula. So negative b plus or minus square root b squared minus 4ac all over 2a. Simplify what you can here. The two negatives are going to give me a positive 5 in the front, plus or minus square root. Okay, so 25 minus 20 gives me 5 there, and then in the denominator I have a 2. So this, remember, can be split up technically into 5 plus root 5 over 2 and 5 minus root 5 over 2. But this plus or minus is perfect to indicate that you're going to have 2 solutions. The plus or minus is great there. So really, all you have to add to the beginning of your answer is the negative 1 that you divided by. This right here is 3 solutions, which if you look on your graph, this graph does cross the x-axis at 3 different places. So this would give me a decimal, but you're just going to leave the exact answer as a radical. Okay, last page here. The equation is graphed below. Use the graph to solve the equation and find the roots of the function. So again, we are going to use synthetic division. We're looking for the exact 0 that it's crossing there. So I'm going to be using negative 5 for my synthetic division. Writing down my coefficients here. Negative 10, negative 32, negative 35. Now, I know that this is going to have 3 solutions because it's a cubic. But looking at the graph, it only crosses it once, which tells me my two other solutions are probably going to be imaginary, okay? Which we are able to find. We did that a few sections back, so this should be no problem. So I really encourage you to pause right here, go through the synthetic division. You're going to get a quadratic, use the quadratic formula, and get your two other solutions. Again, this kind of graph gives me a hint that it's going to be imaginary. So go ahead and pause now. When you come back, the answer will be ready. All right, check your answers. So as we thought, we have some imaginary answers here because we do not see this graph crossing the x-axis two more times. So our answers will be imaginary. When you have a negative inside the radical, you just pull out that as an I in front of the radical. It's possible that you have your answer with the negative here instead of here. As long as you understand that they are the same thing, you should be okay. Okay? Okay, for number 5, again, I'm looking at the roots here. And this one's not quite going exactly through. This one's not quite exactly going through. So I'm going to be using a +1. And then my coefficients are here. It looks like this time I do need a placeholder for my x. So I'm going to make sure I put in a 0. A good indicator there is if you forget to put the placeholder, you're not going to get a remainder of 0. And so that's how you know that you're wrong, right? Because when we're solving, we are giving you roots, solutions, factors to divide by, so your remainder should be 0. So here I go, bring down the -1, multiply, add, multiply, add, multiply, add, remainder 0, that's good. Now I have -x² plus 3x plus 3 to work with. This is a quadratic, so I can try to factor, or I can use the quadratic formula. So I know this is not going to factor out nicely because it doesn't go through exactly at nice zeros there. So I'm going to use the quadratic formula. So I have -b plus or minus square root b squared minus 4ac all over 2a. Okay, so I go through and simplify my radical here. I get 21 over -2. So try to break down the radical 21. Simplify any negatives if you can. Remember that plus or minus takes care of the negatives there. So this would simplify to 3 plus or minus square root of 21 over 2. So my final answer, I can't forget about my original, +1, and then my simplified quadratic formula answer. So this would be my final answer for number 5. Okay, 3 solutions, again, because of that highest exponent, this is a cubic. Okay, last one, I'm gonna let you go ahead and pause here. When you come back, the answer will be ready. Just wanna make sure you can practice, so look exactly where it crosses. Think about, is this graph even crossing the x-axis anymore? That's a big hint. Chances are it's gonna be imaginary. So go ahead and try it from here. All right, hopefully this is what your answer looks like. So I divided by that -1, making sure I bring that -1 in my final answer. Don't forget about that. I saw that my graph wasn't actually crossing on the x-axis, which was my big hint for that imaginary answer. Remember to simplify your fraction if you can. This one did simplify. So here I have 3 solutions, my -1, and then my 1 plus or minus I. That plus or minus indicates 2 different solutions. Okay, and that is the end of this section.